Let's start with the implicit flow, the simplest of the user-initiated OAuth 2 flows. It's very similar to the standard OAuth 2 flow we covered in the last chapter, but with some deeper technical details. First, we have the familiar OAuth 2 roles: the resource owner, the client, the authorization server, and the resource server. The authorization server has a specific endpoint called the authorize endpoint. This is where the resource owner is prompted to authenticate. The implicit flow is designed specifically for browser-based applications that run directly in the browser, like Google Chrome or Firefox. Because these are public-facing applications, the OAuth 2 client must be configured as a public client in the authorization server. If you remember from the last chapter, a public client is an application that cannot securely store sensitive credentials like client secrets. The authorization server presents a user interface, a login screen where the resource owner is redirected when interacting with the client. This UI is part of the authorize endpoint. In most authorization servers, you can customize this interface to align with your organization's branding or theming requirements. The process begins with the resource owner initiates the flow, either by clicking login or granting the client access to the resources. As we have discussed, the resource owner never shares their credentials directly with the third-party applications. Instead, the client redirects them to the authorization server's authorize endpoint where they enter their credentials. This redirect typically happens via an HTTP 302 request. The URL for this request contains several important query parameters. Client ID, this identifies the client application requesting access on behalf of the user. Response type equals token. This tells the authorization server that the client expects an access token in the response, indicating the use of the implicit flow. You might remember from the Photobee demo when the application redirected me to Microsoft's authorization server. Response type equals token indicated that Photobee was using the implicit flow. Redirect URI. This specifies where the authorization server should redirect their resource owner after successful authentication. For security reasons, these URIs must be pre-registered in the authorization server, either as an approved list or using regular expressions like wildcard.example.com. These three parameters, client ID, response type equals token, and redirect URI, are required for the implicit flow. There are also two optional but highly recommended parameters. Scope, this limits the access or actions the client can perform in the API, such as orders read. State, a random string used to maintain state between the request and callback, which also helps protect against CSRF attacks. Again, referring back to the Photobee demo, the request URL had a similar structure: the authorized endpoint, and the query parameters like client ID, scope, response type equals token, and redirect URI. So the resource owner now enters his credentials like an email and password into the authorization server. The authorization server verifies the credentials, ensuring everything is correct. Once verified, the authorization server shows the resource owner the requested permissions scopes in a user-friendly description and asks the user to review and confirm them. For example, in the Photobee demo, I was asked by Microsoft to review and confirm the permissions scopes that Photobee needed to access my data in OneDrive. Note that while this step is highly recommended for security purposes, it's still optional and can be configured based on your business needs and requirements. If everything looks good and the user approves, the authorization server generates an access token and redirects the resource owner back to the client's redirect URI specified in the initial request. The response is sent as a URL with a fragment identifier containing the access token and other relevant data, like the token type and expiration time, all within the URL. After the fragment identifier, you will see the access token type, for example bearer, which means the token can be used by anyone who holds it to access the resources, and expires in 3600 seconds, meaning the token will expire in 1 hour. The response also includes the state value, which should match the state value in the initial request. This is used to prevent CSRF attacks by ensuring the integrity of the transaction. After receiving the access token, the client can now use it to authorize its request when accessing user data or performing actions on behalf of the resource owner by presenting this access token. The resource server then validates and verifies the access token either locally or by making a request to the introspection endpoint of the authorization server. We have covered both mechanisms, local validation and introspection, in the token validation lesson. If the token is successfully verified, the resource server provides the requested resources to the client, completing the process.